Yeah, I have another physics puzzle for you.
Again?
Yup, listen to me. I'm going to throw a ball vertically upward with an initial speed of u. And it reaches a maximum height of h. And just at the instant when it reaches the maximum height, I'm going to throw a second ball upward, also at an initial speed of u.
Oh, I know. They will collide.
Yes, but that's not my question. My question is, at what height, in terms of h, are they going to collide?
Oh.
Okay, let's begin. I have two ways to solving this problem. One is boring and one is quite elegant. Let's start with the boring method first. The boring way is to use lots of equations. We first obtain the expression for the maximum height reached by the first ball. For that, we just need to use the equation of motion, v squared is equals to u squared plus 2as. In my previous video, I've already shown that the maximum height for a vertical throw is given by u squared divided by 2g. Now let's bring in the second ball. Now suppose at the point where the two balls meet, the red ball has fallen down a distance of s1 and the green ball has gone up a distance of s2. So using the equation of motion, s equals to ut plus half at squared, we can write s1 to be 0 plus half gt squared. And we can write s2 to be ut minus half gt squared. What we can do now is to add up these two equations. So on the left hand side, I have s1 plus s2, which is of course equals to h. And the right hand side, after these two terms cancel each other out, all we have is ut. So now we have an important piece of information here. The two balls are going to meet at t is equals to h divided by u. All we have to do now is to substitute this value of t into this equation here, which gives me this. So what happens here is I've replaced the t here with h divided by u. And from here to here, I've replaced u squared with 2gh. How did I get that? Well, it comes from here. See, from here, u squared is actually equals to 2gh. And after some simplification, we get s1 equals to 1/4 h. So now we have the answer. The two balls are going to meet at the point where the red ball has fallen down 1/4 of the way and the green ball has traveled up 3/4 of the way. Okay, now let me show you the elegant method. This is the velocity time graph for the green ball. It's a vertical throw, so it starts off with the maximum velocity of u and decelerates at the constant rate of g until it reaches the maximum height here. Now remember, the area under the vt graph is displacement. So this big triangular area here would represent h. This is the velocity time graph for the red ball. Because it's a vertical drop, its velocity starts from 0 and increases at a constant rate of g. Now let's pick on this instant in time here when the two velocity time graphs cross. At this point in time, the red ball will have fallen down a distance given by this red area here, whereas the green ball will have traveled up by a distance given by this green area here. Wait a minute, have we found the answer here? Isn't this the instant in time when the two balls meet? Because the distance traveled by the green ball plus the distance traveled by the red ball is equals to this distance here, which represents the distance h. So we know this is the instant in time when the two balls meet, and the red ball will have fallen only 1/4 of its way down, and the green ball will have traveled up 3/4 of its way.
What? You solved the problem by looking at triangles?
Yes, why not? I know good things are going to happen when I have similar and symmetrical triangles.